Hello, my name is Samuel Daya, and today I have something very fascinating to share with you all. So, for the past 6 months, I have been working with a group in developing a project that is creating a law-based turn-based game. And now in this game, I was in charge of creating a turn-based combat system, in which I did building it completely from scratch. All I had was essentially online APIs, forums to see what I could do, and essentially just other people to help me whenever I ever need it. But in the end, I went through the entire trouble of creating this very intricate and very complicated turn-based combat system that I would like to share. Now, very big problem with this combat system. It is very nested. It is like a web and it all interconnects together. I would like to share just maybe one or two few scripts, but by just only explaining those ones, it leaves out all the things it can do without being connected as a group. So the way I will be presenting all this is in a 3-part series that goes over the core aspects of this turn-based combat system. We have number 1, characters, number 2, the systems, and number 3, UI. Now, again, I was very proud in creating this system. This system is a new and improved version of previous iterations that I have created. And this is what I would say is the current peak this turn-based combat system can become. It is very scalable and is very modular. You're able to add in and implement new features pretty easily. And it is incredibly easy to read and easy to understand. Without further ado, let's get right into it. Before we dive into the core aspects or core parts of the turn-based combat system, we need to take a look at the global combat namespace. In this namespace, it contains a whole bunch of different enumerators and classes and will appear quite frequently as we go throughout the scripts. And so first of all, we have the damage type enumerator. Right now, we have 3 in this example. We have basic, physical, and magical. It's a highly modular system. So if we wanted to include more damage types, we can, like fire, lightning, etc., for a more elemental-based combat system. But right now, we also have the character type enumerator, which signifies either player characters and enemy characters. It is really important to differentiate these characters so we don't break the game and access the right types of characters. Next is we have the enemy significance enumerator, which signifies the level of intelligence an enemy will have. Right now we have 2, either being a mob enemy or an elite enemy. With this, we are able to give more functions to elite enemies or even less functions to mob enemies, which they can just use the same attack over and over again. And again, highly modular system. So if you want to add even more layers of enemy intelligence, we can. Next up, we have the targeting enumerator. So for attacks or buffs or debuffs, we can target whoever we want, either targeting the self, allies, enemies, random enemies, all allies, and all enemies. Next, we have a stat enumerator, which acts as keys for a dictionary that we have up and coming, which stores all the stats a character will have. Right now, we have max health, initiative, base attack, physical attack, magical attack, base defense, physical defense, and magical defense. Again, it's a highly modular system. So if you wanted to add even more stats, like we want like luck, even more types of defense, even more types of attacks, we can. But in this example, we'll stick to this 8 to keep it more simple. Next is we have a status enumerator. This is very important to signify whether a character is alive or dead. So we have normal and dead. And this one we can just delete real quick. Next is we have an input selection enumerator. This input selection enumerator helps in essentially highlighting over attacks or actions that we want to do without selecting them or going forward with them quite fully. So we essentially just highlight either a basic skill or second skill. Next up is we have our operator enumerator. This is just a small enumerator, either add or multiply in our stat calculator for stat modifiers. Next up, we also have 2 classes. We have a sorter class for sort descending. This is for our initiative system that we have in the turn order. This helps sort from biggest to lowest. And then lastly, we have a stat dictionary, which is just inherited from a regular dictionary using stat as the key and floats as the values. Now, in this class, it is very important that we also have this custom function inside, which is a float getter, where we just try to grab and access a value from the key. And in some cases, grabbing stats like this doesn't work. So it is best that we have a somewhat of a separate getter just for grabbing values. For the first core aspect that we're going to go over, every script that a character has. So right now for each character, they're all the same guy, just in different colors. This is just for a sample, just for fun shenanigans. Instead of using actual assets that are part of our game, I don't want to leak that, a little too soon. So this time we're just going to use different off-color characters. So In each character, they have 5 important scripts. They have a target, a character manager, character animator, attacker, and stat manager script. Now, with enemies, they get a special exception. They get one more script on them. They get their enemy behavior script. But right now, let us look over what each script regular character has. First, let's look at the character manager. Character manager is just the central hub for everything that a character will have. So here we're able to grab their stats through their stat templates. We're able to grab the targets. We're able to grab the character animator and the stat manager. So all the other scripts have a accessor through here. Then we have their 2 stats that we grab quite frequently. Their initiative and the character type. These 2 are very important as we do need to grab the initiative of a character, so essentially their place in the turn order, and what type of character it is, being a player character or an enemy character. Now, we also do have 3 overrides that overrides Unity's hashcode system. This is important in the sorter that we have in the global namespace. Instead of going through using object hashcodes, we replace it with the initiative. And with this, we're able to sort it all through using a initiative system sorter. Next, let's take a look at the template script. So in our stat template script, it is a abstract class for we are going to have abstract voids that we're going to need to have our characters inherit. And now this is a template script that each character inherits the stats and functions that they're going to have. Next, we have a public accessor to the turn-based combat system. So characters have access to the system itself. Next, for our stats, we have a scriptable object which stores our reference stats, a dictionary for our stats that we get to access and use and update, a status to show whether a character is dead or alive. And now quickly, let's look over this scriptable object. We have a prefab storage here for the reference character. This is good for if we're going to make a roguelike or a procedural game. So our prefabs are stored in a scriptable object which we can easily access and easily grab instead of just grabbing prefabs directly from Unity. And we can also save scriptable objects if we were trying to save it into file paths. Next, we also have a string for our character names, a sprite for our icons, the character type it is, either being player or enemy, and intelligence level for the enemy. And if it's a player, this just gets ignored. We also have strings that stores the name and effects of each type of skill, the basic, skill 1 or skill 2. We have the reference stat dictionary that the actual character scripts will copy. And we have a list for our stats. Now, Unity does not initialize dictionaries or serialize dictionaries in the inspector. So if we need to create a dictionary that we have to initialize on the start of the game, we need to find a weird workaround or pay $55 to get Odin Inspector. I wish I would choose the latter, but I am a student with not high welfare status, so this is what I found instead. So we have this for loop in which we grab the stats in their index, we add it into the dictionary at the index of the stat that we're gonna add in with the stat that we have as a value. What this means is we have a list of stats here and they'll be added into the dictionary in the order that the enumerator is set up. So the first stat will be max health. Max health will be 200. X is initiative. Initiative's 10. And then base attack. Base attack is 20. Now, so on and so forth. Now, I would get Odin Inspector if I could, but finding fun workarounds is very nice too. And this is very important. We need to have an if statement that states if the dictionary is higher than 0. We need to only initialize the dictionary if the count is at 0 or we have no stats, because in some cases we may have enemies or characters be duplicates of each other. We have multiple of them initialized at the same time. So to make sure that we don't overload the dictionary or create errors by creating multiple keys of the same keys, we need to make sure that only one of them run by having only the script run this function if the dictionary doesn't have any stats inside. Now, jumping back to the template script, next we have our private float for health. We store health in the character script instead of the dictionary is because health gets updated a lot and we don't want to break the dictionary by constantly updating it. And next, we do have a public accessor for our private float where we just, in the getter, return the HP, and in the setter, we set that private float within a clamp so it doesn't go less than 0 or more than the max health. We do something similar for initiative, but we do grab it directly from the dictionary and we set it either between 0 or 20. So just like any other TTRPG or tabletop role-playing game like Dungeons and Dragons or Pathfinder. Next, we have a float for defense calculation. We will review this once we go to when a player takes damage. Next, on awake, we initialize that dictionary that's within the scriptable object. Next, we grab our stats from the reference dictionary. And the reason we do this is so that we have a dictionary that we can update and freely use, and a reference to look back to when we need to revert back to our original stats. And then this is how we grab our turn-based combat system. We just find the object with the tag of manager and grab the script from there. On start, we set our health to the max and we update our health bars. For enemies, they go through the target script and update their health points through their grabbing the health and max health using a slider. And for players, we update a UI display that stores all of the characters' health and also their name and icon. But we'll go through these two parts once we go through their respective scripts. Next, for being an abstract class, we do have 6 abstract functions. Each character script must inherit the basic attack, the preparation for the basic attack, skill 1 attack, and skill 1 preparation, skill 2 preparation. Now, for enemies, right now, they don't use skill 2 and skill 2 prep, but if we were to create even more like levels of intelligence for an enemy, they might have access to this or in a different way. We have 3 different types of functions for taking damage. We have the regular taking damage and we have healing. And then we also have a damage checker. Now, first, when you take damage, we grab the amounts that we're taking and we also have the damage type. So first, you check the type of damage it is, either being basic, physical, or magical in this switch case. So for basic, the calculation is set at 0. Physical, you take physical defense stat in the dictionary. For magical damage, you take the magical defense. The way it is calculated is health. Subtract the health by the damage inflicted, multiplied a percentage of defense plus the base defense in brackets divided by 1,000, and you subtract it from what? The way it's calculated is that each one value in the base defense or physical magical is 0.01 percentage. When you take damage, we update the health bars. And then if health does reach 0, the character is officially dead. Now in healing, you take the amount that you heal by and you increase that amount. Very simple, just a healing function. And then again, update the UI that is for those healing functions. Now that we've taken a look at the templates, let's take a look at these 4 character scripts that we created using that template. So over here, we inherit that template and we have our 6 override functions. With attacker, he just has in each preparations, he just changed the targeting to targeting enemies. So we select through the enemies and find the one that we want to attack. And then when we do attack, we go through the combat system, we grab that target enemy, we grab their stats, and they take damage based on our attack that we want to deal and the damage type that we want to deal. And see, we have the same thing with our skill where we deal magical attack and it's magical damage. And again, physical attack and physical damage. We could per se change it to magical as well. So they'll use magical defense based on our physical attack number. But that's for intricate developer and complicated RPG type of mechanics. And now with our different types of characters, we also have a debuffer where he stores stat modifiers or magical debuff, physical debuff, and he places those modifiers in the target character's stat manager, and they just add that modifier in their list, and then they take a bit of damage. Now you don't just target enemies with these modifiers. You can also target allies, where with defender, he has 2 magical defense and physical defense modifiers, and he's able to change the targeting and target allies instead and give them this modifier which increases their defense. And now with the healer has that heal function in which they heal characters instead, where they target allies and then give them more HP. With this one, they have a all allies targeting, and the way that works is we just have a for each which selects all player characters and gives them healing by 25. Since we touched briefly upon stat modifiers in the character scripts, let's take a look at it now. In stat modifier, we have it be serializable, so we're able to edit it in the inspector. We have 2 strings, we have the name and effect, 2 integers, the value and duration. We have a enumerator for our stats, so we can access the target stat using this as the key to get into the dictionary, and operator either to add and multiply. And then we have this copy constructor, so we're able to copy the values of a different stat modifier into this other stat modifier that we want to copy it from. And now we have this one function which turns to pass, which decreases the duration of our stat modifier. And then we have public getters for each of the stats. We don't want to ever set any of the stats unless through the copy constructor, because we don't really need to, unless we need to reset the duration. Next up in Stat Manager, this is what's in the characters itself. This is what's added into their character prefab. We have the list of the modifiers and an accessor to the central hub script for the character manager. We have our function to add stats. The process of adding stats, it goes through a for each loop where it goes through the mods list. If that name already exists within the loop, we grab the index of that modifier and we reset its duration with the original duration. And now, if it doesn't exist, we just create that stat modifier into the mod list. And then afterwards, we calculate that stat. On awake, we grab our central hub script. Next, to calculate our stat modifiers, we grab our stat dictionary and reset it back to our reference. And then we update our stats. We have two types of functions. One to calculate when it is not on our turn, and one to calculate when it is on our turn. If it is on our turn, we have to lessen the duration of each stat. And the way past turn works is, as long as we have stats, goes through a for loop where it checks first. If any of the durations is at 0, it removes it from the list. And then next, after that check, we actually decrease after we check first. So we are able to update the stats. Now in stat updater or update stats, we have another for each loop that goes through the list. We go into switch case based on the operator. So against add and multiply. And then we have another switch case depending on the stat. If it is an initiative, we have to convert it to integer. That's why there's this additional switch case. If it's anything else, we just grab the stat and add the value into our target stat. In multiply, again, same thing with initiative. We add the stat into our initiative multiplied by the value of our stat modifier value. And again, we have to convert it to integer. And if it's anything else, we just do it regularly. We take our target stats value, multiply it by the value of the stat modifier, and then just add it to our stat. So here I'm going to show how stat modifiers work in real time. So right now we have two enemies and each of them has the stat manager. They currently have no debuffs on them. So let us go hit, let's say the left one with a magical debuff. Alright, the left one has been hit with a magical debuff. And let's see, this one now has the magical debuff. It decreases their magical defense by 100. And as you can see, it lasts for 2 turns. And it's currently just subtracting using an addition operator. So it's being subtracted. Now, we also deal a bit of damage. So they'll go down to 80 HP. In terms of damage, our attacker, he deals 100 magical damage. So let's say we are to attack the guy on the right with 100 magical damage. And in his reference, he has what seems to be 100 magical defense. So essentially around 10% of that damage will be knocked off. So let's go hit this guy. Boom. He's at 10 remaining hit points. And then next we also have our defender. So let's give some defense to our back to our debuffer. Let's give him defense. Ooh, does block that damage, debuffer. So let's take a look at Mr. Debuffer. Boom. He also has his own modifier. He has that defense where it increases the value by 200 in its addition. And because his turn is active, the duration does go down. Same thing with the guy who got hit with a debuff. His duration went down because it was his turn. And now we can also reset that duration by hitting him again with the same debuff. And since it's the same debuff, it'll just reset it. Boom. Instead of creating a new debuff, it'll just reset. Now, let's set this guy back to 100 hit points to be generous. His HP won't be displayed. It won't be automatically updated because that's not being called right now. But he has 100 hit points. With the other guy, since he didn't have a debuff, he still had his 10% defense. Now, this guy, his value is decreased. So instead of having 100, he will be down at 0. So let's see what happens if he gets hit. Let's see where his hit points are going to go down to. It goes down all the way to 0 and he is classified as dead. So this is how stat modifiers work in real time. Next, let's take a look at our target script, which is within the characters. Now in the target script, we have 2 voids, whether select and deselect. Now this activates this target game object which is for each character is this spotlight. Now this spotlight signifies whether the character is being targeted for a action or attack for a buff or debuff. It just turns on and off, and as you can see in the game view down below, that's what changes. Is very bright and just turns off and on. And now this is where that game object is stored. And then we also have a transform for a camera target. The reason we have a different transform as our player characters could have a transform different from where we want to point it to. So let's say the transform is at the ground. We don't want the camera looking down at the ground. So we have this other target where we stare at that right in the middle of the character instead of at his toes. And next we have a slider bar for our enemy characters and the object itself. So we could have that object look at the player so it doesn't just remain still. And in this function, we just grab that float HP and max HP, set the max value first. Very important you set the max first and then the value. I ran into an error before where I set the value first before the max, which causes the value to be technically 1 and the max value being set afterwards, because you can't set the value higher than the max, which is by default 1. And now after the target script, as you can see in players, if you look at target, they don't have the HP bar object. In player characters, they don't access this at all. Only if you're an enemy, it will ever get access. So having it remain at none will be fine. Now the last part for our characters is our character animator. Character animator is essentially how all the scripts are actually being played. First, we need to grab the animator, manager, and the combat script itself. On awake, we all grab those functions, and now we have essentially triggers for all the animations that we need to play. It's a basic, skill 2. We have a way to reset those triggers. And then we also have an end of turn function and 3 functions that activate this code for that is within the stat templates. And then we have an enemy function just in case the enemy needs to take their turn. This is how their code gets access. We have death function, which sets the death animation. This deletes the game object, which could be set on an animation event at the end of the death animation if we wanted to. I keep it off because it is very funny to see a body on the ground as you're still playing the game. We have an intro function for when the game starts. There's an animation that plays, and then the win animation, which is the same as the intro because the intro is a hip-hop dance. Now, in each animation for each character, their animator, they have these 5 animations. This is the intro, this is the death animation, this is the basic attack, this is their skill 1 and skill 2. This is how each of the functions are actually being activated through animation events, where the actual function is being called, and then at the end of the animation, it calls that end of turn function. The reason we have animation events is because this game or this combat system is purely events-based. There is no update function whatsoever. This was in my way of a challenge in coding a turn-based game, which I realized you don't really need a update function to call every frame. I also wanted to optimize the game a little bit, so I have a little bit of leeway in when I make unoptimized decisions. Now in the basic attack, you can see that's what happens. In the intro, there's no animation events that needs to play. Skill 1, same thing. We have our skill attack code in this animation event, and then the end of turn function right here. Skill 2, similar thing. You can see him go flying. You have skill 2 here, skill 2 up there, end turn right there, and death animation. Very silly. Now, each character doesn't have the same animator, which is really nice as long as the setup of each animator is the same. So with here, these two kind of look the same, but this one stores skill 1 in attacker. In debuffer, this stores debuff 1 animation instead. We have 4 different animators. This is just the template that we're basing out of. And then we have different clips for each animation that runs different codes within them. Each animator, it runs essentially all the functions the character has. So let's say we want to take a look at debuffer. In debuffer's animations, he has debuff 1, which stores his debuff skill, his skill attack code, and his end of turn. And then in debuff 2, it stores the same skill 2 attack code and his end of turn, just in a different time and position. So it all just works the same as long as it has these 2 animation events. So that's the end for this part where we went over the core aspect of players and characters. The characters on its own already are a very intricate web of scripts that all call within each other. that all rely on each other to work and build up to give the player a very interactive experience and having the freedom to essentially play as whatever they want to do. In the next part, we'll go over the different systems within the combat system. We have our camera controller, input manager, party manager, targeting system, turn-based combat system, and our turn order system. And we'll go through how those 6 scripts all work together and weave a web that essentially gives the player side inputs. And that is all for this part, and see you in the next one.